Good day, everyone. Today's video is going to focus on ArcGIS Pro and some of the tools that we commonly use to maintain files, update them, get them in a more usable format for our purposes, depending on what the analysis is. With that, I've already loaded up some data that we've seen in other videos. We use these in class. We have Little Rock in front of us. The city boundary and the streets are showing. We also have unsafe and vacant properties, ag, assault, and homicide for calendar year of 2021. We also have the block group file that's on their data portal. And we also have our school block zones for Little Rock. A little easier to see if I turn off the streets there. But we have different layers that we can do different things with. Primarily for this video, we're going to cover how to dissolve, clip, use the near table, and then also how to run the average nearest neighbor. So 4 tools pretty commonly used depending on what you're trying to do. And we'll get into more tools as the next couple of weeks progress. With that, say we're interested in dissolving our lovely school zone. So this file, if we open it again, has the elementary, middle, and high school blocks and how the feeder system of how at the elementary level, what it feeds into the middle and then the high school. With that, say you're interested in, and for an example of what we were working on, one specific school zone. We were working with Stevens Elementary Zone. We also did Mapleville Middle School. So with that, you end up having multiple blocks for one school zone. So when I say that, if I were to do a select by attribute here, and if I were to do elementary and default is equal to, and let's do Stevens again, it actually consists of 43 individual blocks or block zones that create Stevens Elementary Zone. With that, if I were to export this out, and we've done this in prior videos, we would still be left with these boundaries, and you can see here the breakpoints or the edges of each one. With that, you might be just interested in the overall school zone, and you don't want it broken down by the zones within it, because you just want the specific larger area for the entire Stevens zone. With that, I'm going to clear this out and go over how to dissolve. With that, if I hop up into my top toolbar, click on analysis, and if you don't have this popping up, you probably need to sign in. With that though, this brings up some of the commonly used tools. You can customize this to have other ones in it. This is the default one. I kept it this way for these videos, but you can customize this to show what you want. With that, you're going to see a lot of cool tools that you can use, integrate into your work, and make your life a bit easier. What we essentially want to do is, and as you hover over shows you what it's going to do, we want to dissolve our boundaries. So we want to dissolve it based on a variable within it to create a new spatial layer for us. So I want to dissolve our school zone boundaries. So I'm going to insert my blocks, not block group, school blocks. Change the name here to school zone elementary, and I'll put dissolved at the end just so I know. And it's going to ask you what you want to dissolve based on. So for this specific one, I'm interested in dissolving all of these boundaries based on the elementary school or zone that it's attached to. Could do the same for middle and high school. For now, I'm good with this. I'm not going to worry about showing you the statistics and creating some of this. That's a future video, more advanced. But when I click run now I'm left with individual or unique elementary schools. So when I open this attribute table, we can now see that we have 20 different rows, and we each have a different elementary school zone. So if I was still interested in Stevens, you can see now still highlighted, it's the one here. But I would turn this off, you can see it's the same zones underneath it. With that, we've dissolved those boundaries to give you the entire school zone. You can export this out as its own layer. Keep in mind, since I have this one selected, all I would do is still right click on the layer I want to export it from. I'm going to export this one. So we're going to use this in another video here in a second, or another tool. It's going to be Stevens zone. Click OK, and we're good there. I'm going to come back and clear my selection, close this attribute table. I'm going to turn off these 2 layers to where I'm just left with the Stevens elementary zone. With that, update the symbology just for an outline. I just want to see the outer perimeter of it, and we're good to go with that. And you can dissolve different types of layers. You can do streets as well. When I say that, it would turn all the streets into one layer. Different, we get into that, and I have a video on it when you want to re-break it or planarize it itself. But for now, we're in good position for what we've been working on in class and what we would use it in the future. With this, the next one is an example of clipping. So when I show clipping, and Little Rock has this available on their data portal. Right now, the underlying one is the block groups for Little Rock for the census year 2020. What you can see is these were selected out based on what the city boundary intersects. So that's why you have some that go beyond the border. And you can see what that looks like. It's pretty handy. It's a newer layer that Little Rock has put online. The issue is, if I turn on the crime data, it's an example of this. Crime data, for example, won't go beyond our boundary here, or should not. So you're not going to have crime in these outer portions or part of the block groups because they're not in the city. With that, you might be interested in then clipping this larger block group file based on another boundary file, this one being the Little Rock City. With that, what I recommend if you're using this for further analysis, if we open this attribute table, it does give you or provide you the ability to add in your land area. You can do new calculations to where you have the original. If you want to do square miles, you can do that. You have your land area before, and then once you clip it, you're going to have smaller polygons or block groups on the outside because you're slicing those. So you're not going to have the same area. So if you're trying to use, say, population or any of the social measures, you need to proportion those out based on the clipping that you're doing. With that, though, let's come back up to the analysis tab. We have clip that comes up to the top, so we're good there. We can click on this one. We want to input our block groups, and we want to clip it based on our city boundary. We're good there. I'm fine with how it's being saved because it puts the clip at the end. And when I do that, I'm going to turn off the original one here at the bottom. And now you can see this is clipped to the city boundary file itself. Again, you might wonder, well, where did Stevens zone go? This is your drawing order. So if I move this back up, you can see where Stevens is within that. I can even move the city boundary on top so it's a darker outline. But we can see now we have the block groups clipped specifically to the city of Little Rock. With that, another example is if I turn on our streets, and I'm going to turn off our block group, and say I'm interested in only the streets that are within Stevens Elementary. I want a subset of that because I'm going to make a map specifically on Stevens Elementary zone and say crime and other things that are occurring within it. I can do the same part when it comes to a clip as well. All I'm going to do is I clicked it again up here to reset it. I'm going to input my streets layer. I'm going to clip it based on my Stevens zone that I just created. And I'm going to just rename it of Stevens Streets. Hit run. And once I turn off the entire streets layer, I'm now left with a subset of streets in here that represent the ones only within Stevens Elementary zone that I used to clip it. So two examples of how you can clip data, be it polygon to polygon or a line file to a polygon, being the Stevens Elementary. With that, some other work that we've been looking at are, say, unsafe and vacant properties. I'm going to turn off these other layers. And then crime itself. So a lot of literature will look at the presence of vacant property, unsafe. These are land bank properties themselves, city owned, and then nearby crime. The crime layer that we have is ag assault and homicide for 2021. So we might be interested in how close are these ag assaults and homicides to these unsafe vacant properties. So with that, we can actually look at this and generate a near table, which is pretty handy. It'll actually take each individual crime point, our ag assault and homicide, and find the closest unsafe or vacant property for us. You can see here I'm in that analysis tab, and I want to generate a near table. There's a couple different options in it, get into them in other videos, but we're good to go here. I'm going to input my feature. I'm going to input my ag assault homicide of 2021. I want to find as close as it is to unsafe vacant properties. The cool part here is, say you had multiple layers, you also had gas station, liquor stores, parks. You can put all of those in here so you can create a near table based on multiple other places of the built environment itself. So pretty handy that it has that built in. With that, I'm fine with how this is being saved. Generate near table. For this, find the closest location. Planar method is fine. Distance unit, I'm going to choose feet for our purposes. 5,280 feet in a mile, so just keep that in mind when we look at that. And we're good to go and click run here. So since I asked it to generate a table for me, yes, it gives you all the good marks here, but also as a standalone table in your table of contents over here. So if I were to open this table up, we're now going to have our in FID and near FID. So the FID here represents the specific identifier for that crime. So this is FID 0. So if I were to open this ag assault, FID 0 here is this specific crime incident that's reflected here. Same for 114 with our unsafe vacant property. That would have an FID specific to that one as well. And we can see that one's just about 1,400 feet away, the nearest part to it. The cool part is within this table, we can run some basic statistics for us. And with that, if I just right click on this near distance, click on statistics, it's going to give us some descriptive statistics built in, some nice charts, and we can see the mean. Our average here is just over 2,000 feet, a median of about 12 to 1,300. With that, we know it's not equally distributed since the mean and median aren't the same. We can see that even on our kurtosis value down here, but we can see that we have just over 3,400 incidents. Standard deviation's rather large itself too, but we can see the minimum of 20 feet and a maximum multiple miles away, just about 4 miles away. So it gives you some good descriptives of where the data lie. If you can't remember, the median is the 50th percentile. So at least 50% of our homicides in ag assault in calendar year 2021 occurred within just about 1,300 feet of an unsafe or vacant property. That means the other 50% occurred beyond that. We can see that with the average there as well. We have a high value up here of about 4 to 5 miles that way. So it's a good example of how to use these statistics here. With that, now let's get into, well, what about these ag assaults and homicides? Yes, we know they're near some unsafe and vacant properties, but are these clustered? Oftentimes when we look at our hotspots, and we'll get into that in the near future, but we want to know, are these points closer than what would be expected by chance or random chance in the same amount of area? So to do that, we also have in our tools part, and this is where we'll become more familiar with this in the coming weeks, click on our toolboxes, scroll down to our spatial statistics. And this is what we'll be getting into, spatial analysis tools and our statistics, and we want to analyze patterns. And to get your feet wet, we just want to look at your average nearest neighbor. So on average, how close is one crime to another one versus what would be expected by chance. So this is where it will allow us to identify if it's significantly closer than would be expected by chance or not. So with that, we're going to input our crime data being ag assault and homicide for 2021. Euclidean, straight line as a crow flies, distance is fine. And we're going to generate a report. Area-wise, that's asking how large is the area itself. It's based on the coordinate system. So Little Rock's about, I just blinked, 122 square miles. We're going to let it run based on the points itself by default. We can get into that later. We can change the environment as well. We do have a coordinate system. I'm just going to make it the same as our input data. Click run. And this is when I say generate a report. It should give you an HTML document. When we ran this in class, it struggled to make this as a clickable link, but it did generate in the folder itself. But when it does output, let me drag it over, we get a nice little summary sheet that's describing the data that we're looking at. So based on our z-score and p-value here, we can identify that our data, the ag assault and homicide for 2021, is significantly clustered. We can see that based on our expected mean difference. So this is if it was random chance we put the same amount of points up on the map, we would expect the average distance between any of them to be about 656 feet. Within our data itself, the calendar year of 2021, we found our observed average or mean distance to be just about 134 feet. So we can see a drastic difference there. We can see based on our z-score calculation and our p-value that it's highly significant. So this is a good summary here of the findings itself and the significant clustering itself. There's a less than 1% likelihood that this clustered pattern could be the result of random chance. So it summarizes it well, especially for students that haven't had social statistics yet or social data and analysis, even grads that are getting used to it again. It's a nice table and report that talks about your data itself. With that, this is an introduction to some of the tools that we oftentimes use in crime analysis work, just spatial data itself. Keep in mind, we've also already used our spatial join. We've just done it different ways to where some of these tools we'll get into, we'll use some more than others, but it's good to know that these exist and they're already boxed for you in a nice area up here. If there's any questions, feel free to reach out. Until next time, bye.